sound, an existential and fundamental part of our reality. From the slightest whisper to the roar of a rocket, from sounds that we barely perceive to sounds that we can feel. Sounds can evoke fear or excitement or even move us to tears. But can sound move more than just our emotions? Can sound move objects in defiance of the effects of gravity? Traditions the world over speak of large blocks used in ancient megaliths as having been moved and raised by sound, in some cases not just individual sounds, but music. This shouldn't sound like too much of a fanciful question, as sound, which is the basis of music, results from vibrations of air molecules as a result of mechanical displacement or energy discharge. And we know that mechanical energy can indeed move objects against gravity. Repeated sounds or regular sounds are known as rhythm, and music is the melodious and harmonic arrangement of rhythms. I came across the following article during my researches into sonic technology. It discusses realistic techniques which could have been used to build the pyramids based on experimental scale models. Mud canals, levers, counterweights, and interestingly, acoustics are also discussed. Under the section Acoustic Energy for Shifting Large Stones, the author reports on scale models indicating that a team of around 20 men could generate the needed amplitudes, vibratory energy, and impact momentum to shift 5-ton stones the last short distance into the tight formation of the pyramids. The idea is that this energy could be generated by swinging a 500 kilogram or 1,100 pound wooden battering ram suspended by straps from poles that are shoulder yoked between working pairs, just as shown in the figure. To quote the article, by swinging the ram back and forth like a pendulum, slowly building up momentum until the ram impacts on one end of the stone, sufficient acousto-mechanical energy is produced to shift the stone along the top of other stones without wooden rollers. Mathematical predictions and the 1 to 1,000 scaled down ratio model, in other words 200 gram wooden ram and a 2400 gram concrete block, shows that although the stones shift only in very small increments, it would still be moved in a well-controlled manner and into a very precise position. Now this conjures up comments by some pyramid investigators who said that it looks like the great blocks of the pyramids and other megaliths were simply tapped into place, and so precisely that not even a razor blade or a piece of paper could fit between the adjacent blocks. So the article goes on to say that for 10-ton stones, 2 teams would be needed, each with a 500 kilogram ram. For 20-ton stones, 4 teams would be needed, and so on and so on, all uncomplicated applied science. Now, of course, some might say that a ram or pendulum is not the same as music, but is only rhythmic mechanical energy. But what is music but a harmonious arrangement of audible mechanical rhythms? So the principle is exactly the same. Now I attempt to demonstrate the same techniques with my own models. Here I have a pendulum with a heavy weight and a stiff bouncy ball on one end. This end will impact the stone strongly but without damaging it. Each impact moves the stone forward just slightly. Now what if we place the pendulum ram and stone on top of a platform with the stone held down to the platform? Setting the pendulum ram in motion moves the entire platform on each impact as shown. Now from here, we can try to mechanize this. In this clip, the pendulum ram is replaced by a spring-loaded electromechanical vibrator, which oscillates at the resonant frequency of the springs. The springs are loaded by a 2.5-pound weight plate, which impacts the PVC barrel each cycle. Again, we can see here that the platform and any load on it inches forward. But we can refine this even further by attaching a small metal diaphragm directly to one end of the PVC pipe. A magnet placed on the center of this diagram is repelled on each peak cycle of the electromagnetic field from the coil. Tuning the frequency of the coil to one of the resonant modes of this PVC barrel generates sympathetic vibrations sufficient enough to again move the platform and any load in a well-controlled manner. The vibrations also make the loaded platform easier to push or pull. Now, still refining this even further, we can make a homemade PVC air horn. The principal part of an air horn is the pressure chamber. A long pipe fits inside this chamber and forms a breachable seal between the pipe and a flexible membrane which functions as a diaphragm. Blowing into the chamber pressurizes the air within it. The pressure is strong enough to temporarily separate the seal from the end of the pipe, which allows air to escape and the pressure to decrease. With the resulting decrease in air pressure, the diaphragm returns to its normal equilibrium position and sharply taps the end of the pipe in doing so. This pressurization and rarefication cycle can occur hundreds, even thousands of times per second, creating a frequency of taps. The closer this frequency is to the resonant frequency of the long pipe, the stronger the sound will be. So in effect, the air horn is working on the same principle as the mech horn that was previously demonstrated, but just in a more refined and familiar manner of a horn or a pipe instrument. Actually, many musical instruments operate in this manner and are called or classified as membranophones. Drums, gongs, tambourines are all essentially huge diaphragms. It's really just a matter of how that diaphragm is actuated, with air horns relying on compressed air and drums, gongs, and tambourines on percussive energy. Placing the air horn on a similar type soundboard platform as used with the mechanical horns previously, we can see that while loud, it does not move very much on the acoustic waves. There's a couple reasons for this. Firstly, the sonic coupling of the vibrations to the board is not as efficient as it could be. Taking the air horn off of the soundboard and placing it directly on the ground improves the action somewhat. But mostly it's because the diaphragm, being made of plastic, is simply not massive enough. A heavier diaphragm, as well as a larger resonator, would generate stronger vibrations, as we've already seen. But of course, a heavier diaphragm would also require greater input energy, likely far greater than that which could be produced by compressed air from human lungs alone. It seems that it would be better to attempt to mechanize this process with an air pump and compressor, or to mechanize it by perhaps a primitive steam power or hydraulic system. I will attempt to discuss this in the next video. But that's a good question. Could huge mechanized trumpets, like the Tibetan ragdans, be placed on either side of a loaded sled to help move it via acoustic lubrication? So let's do a recap. We've gone from a pendulum battering ram, a crude form of acoustic energy, to an air horn, a much more refined and familiar form of acoustic energy, proving that the same rhythmic mechanical energy is involved in each increasingly refined incarnation. They are one and the same. And so we could see a hypothetical evolution of this idea from a pendulum ram to an actual musical instrument. And it might not be much more difficult to imagine this technique eventually being evolved to accommodate more mechanical inputs in ancient times with the aid of steam energy or hydraulics. We can look towards Nikola Tesla's steam-powered electrical generator, which also produced powerful mechanical vibrations by pushing a piston up and down rapidly via steam power, for a vision of a device that is both simple and innovative, and would not have been beyond the technical abilities of the ancients. It might be reasonable to picture such a device being created and developed in ancient times to actuate huge tuning forks, gongs, drums, and other vibratory devices with great precision and power to develop a tremendous resonance. These resonant vibrations could be harnessed to move loads, as has been demonstrated. Certainly we could imagine primitive sonic techniques being learned by the ancients by simply observing how stomping on the ground or violently striking a surface would make a nearby object move about, or how strongly plucking the strings of a musical instrument would make a small coin sprawl across the soundboard via surface acoustic waves. And perhaps they then theorized that hundreds or even thousands of people stomping at the same time or in rhythms along with musical instruments might replicate those principles on a considerably larger scale. The ancient legends, as well as accounts of Philadelphian inventor John Worrell Keeley, mention the weight of large objects becoming much lighter or even rising into the air by levitation. And if these techniques were used in ancient times, then why did they fall out of favor? Were they simply forgotten? It's certainly possible. But another possibility is that perhaps sonic levitation and propulsion was simply proven to be energetically inefficient, being abandoned for simpler and more energy efficient methods. So one scenario we could envision is an ancient civilization that was significantly more advanced than even our own current one, which had access to free energy, or that was close to what we would call a Type 1 civilization on the Kardashev scale. A Type 1 civilization could capture and harness all the energy arriving on its home planet from its parent star. In our case, that energy is equivalent to 430 billion joules of solar energy every single hour. Perhaps this is why levitation systems and theoretical anti-gravity systems are often associated with free energy or over-unity energy. If virtually any amount of energy could be harnessed continuously and without attenuation, then it really wouldn't matter how much energy was used. Efficiency would instead be based on ease of manipulation, speed, and practicality, and not energy consumption or cost. For instance, a levitation device could consume 250,000 amps of current every single minute, and would be able to do so continuously for any length of time. The only limitation would be the durability of the conduits, whether they be wires or pipes. Levitation, of course, will have many distinct advantages if energy were no issue. You would be able to lift an object to practically any height without any added infrastructure. But if energy were ever to become an issue, then levitation would probably be vastly inefficient energetically compared to simpler and less spectacular methods like levers and cranes and pulleys, even if those methods were slower. Another scenario could be an ancient civilization that, while not nearly as advanced as our own, was nevertheless still more developed and sophisticated than currently given credit for. These early societies, many of whom regarded their rulers and monarchs as living deities, would likely have had little trouble convincing and mobilizing countless numbers of people and immense resources to build their rulers' edifices. Perhaps we can imagine tens of thousands of people, each seen as human sound generators, some sectioned off for marching and stomping in sync, others with large instruments, others shouting and singing, all working together to acoustically enhance the movement of great stones to ease the burden of those who are physically pushing and pulling the stones. Perhaps later on, technical advances allowed mechanized vibrational devices to replace a significant portion of the participants. But as the level of deification and reverence for the rulers of societies began to decline, and economics became more profit-driven or socialist, then we might imagine it becoming increasingly difficult and impractical to mobilize so many people for such an intensive moving technique, with more conventional techniques coming into favor. Now, some might say that if the ancients were advanced enough to have such a well-developed sonic technology, then perhaps they were also advanced enough to have simpler technology such as wheeled vehicles, much earlier than they're given credit for. I suppose this is feasible, but even today's huge mining trucks like the Bell 75710 and its payload capacity of just under 500 tons benefits from 10-foot diameter super thick rubber tires as well as the strongest of metal alloys. So it seems that creating such a vehicle, especially without sufficiently advanced materials, would be more complex a project itself than the megalith. A wheel made of wood or stone capable of hauling hundreds of tons likely would have been megalithic in itself in order to have the same strength as modern 10-foot diameter rubber wheel, not to mention attempting to make axles, bearings, and a suspension system without the aid of metal alloys. So it seems just as feasible that a well-developed sonic technology will have been employed, especially since there are a number of traditions and cultures around the world which seem to strongly hint at it. So ultimately, we have empirical evidence that sound at its most basic level of singular tones can move or help move massive objects. And it will follow that this ability will be retained even in sound's most refined form, namely melodies and music. As long as one of the notes in that melody or song is at the required resonant frequency, the technique of acoustic lubrication and surface acoustic wave or SAW could potentially work. The resonant notes could either be playing continuously in the background of a song or intermittently as a melody. So whenever or wherever that tone is sounded in that song, the acoustic lubrication or surface acoustic wave principle would emerge. So as an example, if a 25 Hz tone was needed to help move a 5,000-pound stone, then as long as the melody or song has that 25 Hz tone, either continuously or intermittently, then friction would be reduced. Additionally, any harmonics of the bass tone of 25 Hz could potentially add energy if they are played simultaneously in the melody or song. These harmonics would include 50 Hz, 75 Hz, 100 Hz, and so on, all whole number ratios. In addition to acoustic lubrication and surface acoustic wave, evidence has emerged in mainstream science that acoustic vibrations as phonons actually do have negative mass, which could potentially be imparted to the medium or material through which that sound travels. The catch seems to be that an enormous amount of energy seems to be needed. Please see my video, Phonons and Anti-Gravity, linked in the description for an in-depth discussion of this. So the aforementioned techniques could enable not only acoustic lubrication and surface acoustic wave, but theoretically even gravity reduction or complete levitation if enough energy could be generated. So as fanciful as it might sound, what we see is that a melodious song could indeed be harnessed to overcome the effects of gravity, one of those effects being the normal force, which is a component of friction. So the legends do have a basis in reality. Now, whether or not the ancients actually had such a sonic technology will ultimately depend on finding the smoking guns, or rather the smoking instruments, which would be the devices themselves, or preferably manuscripts and pictographs showing or describing this technique. Until then, we will have to be content with these interesting stories and the real-life technologies that they can inspire of overcoming friction and possibly even gravity itself with only the sound of a melody.